Okay, okay, so that being recorded. Okay, fine. Okay, so okay, let me also tell you what is expected in the exam first. So I can COC first. Okay, so let me WhatsApp to you what is expected from the exam. So this thing I think they copy this one first. So you can see I WhatsApp to you the exam format, what it should be like. So there are 5 MCQ, A1 to A5, 10 marks there. Then B1 is mensuration, find the area, find the parameter of 2D object, basically 2D object, okay. So should be alright. So you find the area of triangle, rectangle, and parameter, all this put together. There's some object in 2D. Then there's B1, there's about 16 marks. B2 is a graph of straight line and quadratic curve, about 12 marks. We have went through B1 and B2 already. So today we try to finish B3, B4, B5, B6, alright? So we'll start from B3 first, which actually in the practice test. So let's try to do B3, A and B first. So convert the rectangular coordinate 5, 9 to polar coordinate. So remember what coordinate? Rectangular coordinate means x and y. So basically, part A here, you have x equal to 5, y equal to 9. And one polar coordinate means r and theta. So how to convert them? Draw diagram, right? You find out where is 5 and 9. 5 and 9 here. So you draw a diagram x and y axis first. Okay, 5, 9. So let's say origin is here, 5 is here, 9 is here. So this is the point, 5, 9. Okay, so what is R now? R is a distance from origin to the point you're looking for, and this R here. The formula for R is actually, you find out this X here, you find out this Y here. So R is actually square root of X squared plus Y squared. So X is equal to 5. Y is equal to 9. So press calculator. This is equal to square root of 106 here. So R equal to, press calculator, square root 10.106 is 10.3 now. So this is R. Now, what is theta here? Theta is an angle measure from the positive y-axis here. This is theta here. You measure from this positive y-axis here. So theta will be slightly difficult because you have to know where's the point. Okay, so your theta always between what now? Theta is always between 0 to 360. Okay, theta always between 0 and 3. So your best calculator, you get negative answer, you have to convert them. So you can use tangent theta here. The definition, tangent theta and y over x here. Okay, tangent theta and y over x is the formula. So I memorize this one. R. So theta you also memorize. Then you have to be careful when you find theta, right? Sometimes your theta will be negative, so be careful, convert them, okay, to the 9 over 5 now. So 9 over 5, then you find out what is the theta now. So press the calculator, tangent inverse theta, so tangent inverse 9 over 5, so tangent inverse 9 over 5. 60.94, so 60.94, right? So this is the part A. Okay, so you have to memorize from the x and y, figure out r and theta. Theta is a more difficult part because you have to know where is the x and y before you can measure angle, right? So this is part A. So I mentioned that this is, okay, theta is from 0 to 360. So let's WhatsApp this to you. Part A. Okay, see how it's body there. I still have few people not here yet. Okay. So now move on to part B, right? Part B is the other way around. Convert polar coordinate 3106 to rectangular coordinate, also the other way around. So polar coordinate, as you say, that polar coordinate is r theta here. So r equal to 3 now. Theta equal to 106 now. And you want to find rectangular coordinate means x and y. Okay, so the first thing is draw the point. Where's the point now? So yeah, draw the point will help you to figure out what is x and y. At least to do calculation, you know. Somebody say lesson, yes, alright. Yes, no. Okay, so you have theta is 106, right? So this 0 degree, 90 degree, 180 degree, 270, right? So 180 degree is actually 106 degree is actually direction somewhere until here. It's 106 degree now. the direction is here from origin. Then on the x-axis, right? Then you draw it and then straight line. And this distance is actually equal to 3 now. So this is the point 3, 106 degree. So r equals 3 now. So where is x and y now? So if you draw carefully, this is your x here. So I use a different color here. This is your x here. This is your y here. So how to find x and y? You can use the formula x equal to r cosine theta. So r is 3 now, cosine 106 degree. So this will give you 3 times cosine 106, and this will give you minus 0.82, which you can see the diagram that is negative, which is correct. X negative now, and y is equal to r sine theta. The diagram is not necessary, but you can confirm your answer easily whether your answer is correct or not. If you get a different answer, it's not supposed to be. For example, y is positive now. So multiply out 3 times sine 106 now. And you get 2.88 as expected, positive. Okay, so for this one, you have to memorize some conversion formula. So you memorize this. Okay, you memorize this. For the polar coordinate, you take care for coordinate. So this is in part B, right? Part B of question B3. You can find them in chapter 3 in the polar coordinate. Okay, so this is let's see anybody's. Okay, lucky one. Okay, so I think I still have 2 more students not here yet. Muhammad Hasim and Muhammad Hassan. So and call down first. Okay, Muhammad Hasim first. Okay, so this is part B. So now B3 part C, okay, I have changed the question, so be careful now. Initially, the question was about hyperbola. So I change the question now. Let me work out again for you, right? The question is like this. I'm going to look up answer for you. Original question is hyperbola. Okay, original question hyperbola, but I change it to ellipse now. Okay, this is ellipse question now. So the question change now, right? So because there is no more hyperbola, just ellipse. Okay. The diagram below shows a boat P travel around the elliptical boundary of a lake here. The length of major axis is 300, and moving from east to west, and length of minor axis CD is 200 meter from north to south. Center origin. Write down the standard equation of an ellipse now. So I use the color one. So this question is different from the practice exam because I changed the question early. So, and what is this standard equation of ellipse, right? Something like this. X squared over a squared plus y squared over b squared equal to 1. This is standard equation of ellipse here. So what is A, what is B now? So given to you, the length of major axis is 300. AB, the length of major axis is 300. Okay, so this thing is AB, the length of major axis. So from here to here, from A to B, this length of major axis here, and usually the length of major axis is called 2A. Okay, 2A here. So 2A is equal to 300. So length of major axis is 300 meter from east to west, right? The length of minor axis CD, this one CD here is called 2B. So 2B is equal to 200. So what does it mean now? It means that A is which one? This is A is actually this length. A, right? B is this length. B. So I know A is 150 now. B is equal to 100. So the equation of ellipse in this case is x squared over 150 squared plus y squared over 100 squared equal to 1. And you press the calculator. 150 squared is how much? 22500. So this is x squared over 22500 plus y squared over 10000. Okay. So for this thing, standard equation of ellipse, you have to memorize both equation and diagram, because otherwise you cannot do which one is which one. Okay, equation and diagram. This equation and diagram are on page 312. Okay, equation and diagram on page 312. So this is question B3 part 1. Okay, I change the question, original practice question B3 to the ellipse question now. Let's see. Okay, so let's move on to the next part now. So next part, I find the length of F1P and F2P, right? So the length of F1P and F2P, this is actually second part now. So where is F1P? F1P is actually from here to here. So F1P actually from here to here now. Sorry. Okay, F1P and F2P is this one. What is the length? So there's a formula about this was F1P plus F2P. The formula of this you can, I think is in page 12 again, page 3, 12 again. Okay, so check again. I think this is in page 3, 12, chapter 3, when they talk about conic. So yeah, so page 3, 12. Okay, so page 3, 17. Okay, page 3, 17. Sorry, not page 17, page 3, 12. Okay, page 3, 12. And this is equal to 2a. So to do this, you have to memorize the diagram equation. So memorize formula and diagram. So where is 2a here? 2a is the distance on the major axis now. So this actually is 2a now. So from here to here is 2a. Okay, given the length of major axis is 300. So that's the answer. Okay, so length of major axis is 300 there. So I'll give you part 2 now. Okay, this is part 2, how to memorize the formula and diagram. So F1, F2, right? Add together is 2a. 2a happen to be 300 here. So this is part 2. Okay, then move on to part 3 now. The length of F1, F2, part 3. Okay, so I want to find length of F1, F2 here. Okay, why is this one? F1, F2, right? Okay, in this case, we need something called the distance from the center to focus. So I have this distance here called C. Okay, so for C is a distance from center to focus. And the formula for C is equal to C squared equal to A squared minus B squared. Okay, this formula is also on page 312. So what is A now? We are given that 2A is 300. Okay, length of major axis is 2A, so 2A is 300 here. So A is 150 now. And 2B, length of minor axis here is 200 here. So B equal 100 here. Okay, so basically your A is actually this one, A. Your B is actually this one. So for this, you can find out what I see now is 150 square minus 100 square. So you find the difference is a C square now. So 12500. So C in this case, take a square root here. So it's 50, so 5 is 111.8 now. So I know C is 111.8 now. So you can see from our diagram, where is F1, F2? F1, F2 is just 2 times C. So it's 2 times 111.8 here. So you multiply 111.8 times 2, you get 224. Right? So this one, again, you memorize formula. And diagram. So you know what you are doing, find something what you are finding here, right? Diagram. This is diagram is on page 312. So this is B3. So I tell you, question B3 has part 1, part A is convert, part A and part B are convert polar and rectangular coordinate. Then part C is a coordinate question. Okay, this is what I mean the question in the beginning. So here, if I say in the beginning, right, polar coordinate and coordinate. The coordinate means ellipse. Okay, so this is what B3 all about. Okay, so show you how to B3 here now. Okay, now I move on to B4. Again, I'm going to change the question of B4. So it's a slightly easier question. Okay, B4 is a slightly easier question now. I'm going to show you the question of B4. Okay, so the original B4 is, I have video, but if you want, I can send you the video. I'm going to look at the new question of B4. Okay, so it's not this one, it's another one. Let's B4. Okay, so well, let me show you how to explain to you why the B4 is like this, right? Why it's so special about this question B4 here. This will be the easier question. Okay, so okay, why B4 is about bearing question. Okay, bearing, angle, elevation, all these things. So in the process, they give you information one at a time. So you look at information one at a time and okay, then answer the question. So only show you part A only, right? So what is different? What is good of this question is, I will give you the triangle. Okay, in the question, I will give you a triangle. So you don't need to worry that you draw a wrong triangle. Okay, the triangle I draw for you in the question is always correct one. So don't need to worry about that now. It's just concentrate on solving the triangle now. Right? Triangle given. So this diagram show you the position of three buildings. Okay, one of them is a art gallery and a hospital. Okay, the bearing of hospital from art gallery is 72 degrees. True bearing, yeah. The cinema is due east to hospital. The distance from hospital and art gallery is equal. Okay, from the hospital to the cinema. So art gallery to hospital and hospital to cinema, the distance is the same. What is the bearing of cinema from art gallery? So what are they looking for now? Bearing of cinema for art gallery. So what they are looking for is actually this angle. Okay. So how do you solve this question? You need to find out angle before you do calculation. Okay, angle, then you can find the length, all these things. Okay, so this just part A only. I will not show you part B and part C because this is just standard bearing question. So let's look at angle H first. Before I do that, let's try to figure out this angle first. So angle H what? So from here to here, this angle is 72, right? Same. Okay, this angle is 72. When looking at parallel line, the north pole is parallel line here. Okay, north pole parallel line. So this is 72 here. And then hospital, cinema and due east hospital. So we know that this angle will be 90 degrees. See, from there, I can find out where is angle H here. Hospital, angle at the hospital. Angle H is 72 plus 90. So this is 72/90, you get 162, right? Okay, then look for triangle now, okay? So this angle is 162, and we know that the angle H, okay? So angle A plus angle H here plus angle C of a triangle are in the triangle AHC. Add together, this thing must have 80 degrees. So that means that angle A plus angle C is 180 minus 162, which is equal to 18 degrees. Okay, but then the distance from hospital to art gallery and distance from hospital to seminar are equal. Okay, distance from target. So that means that angle A is actually 18 over 2, 9 degrees. Okay, so from there, I can find the bearing now of a seminar from art gallery. So bearing of seminar from art gallery, this is equal to, from the diagram, you know, is actually 72 plus 9 degrees now. Okay, this part is 9 degrees. So plus 9 degrees. So it's 81 degrees. Okay, so going from the north through bearing. This is how you answer part A. Of course, there will be part B and part C. I will not going to show you what are they now. Okay, this is enough hint that you're going to find distance, you're going to find angle, elevation, all these things. I mean, so this is part A. As I say, before I give you a simple question, because you don't need to worry about triangle. They draw a triangle for you only. You just have to figure out what the angle, what the length, all these things. So this before. Okay, so I move on to the next question, B5, right? I change the B5 also because I want to show you how to do Napier's rule. Napier's rule. Basically, B5 is everything about spherical triangle. So B5 is a question about spherical triangle. So usually could be spherical triangle, we have a sine law or cosine law, depend on the triangle, right? If a triangle has a 90-degree, you use a Napier's rule. If a triangle don't have 90 degree, you can use the sine law or cosine law, spherical triangle. But let me look at question B5. Okay, B5 first. In a spherical triangle, ABC, angle C is 90 degree. Side A is 73, side B is 62, find the side C. So this one got a 90 degree, right? So that means that you use Napier rule, right? Wait, maybe we forgot that Napier rule. It will be provided in the formula. So yeah, three side ABC here. Let's say this is A here, this B here, and then let's say a 90 degree C here. So let's try to draw it so that it look like more 90 degree. Okay, spherical triangle. So that means that this side is A, this side is A, which is 73 degree, angle A, opposite side A, right? Angle B is here, and then so this side is B now. And then we want to find side C. So to solve the triangle, we need a Napier's rule. So remember, Napier's rule look like Napier's rule. The top are two parts, the bottom are three parts. Okay, the Napier's rule. If you look at the Napier's rule formula, this is a spherical triangle. So Napier's rule is actually page 24, and the formula there. So you start at center, which is C now, and this part C here is 90 degree. Okay, then you can go either clockwise or anti-clockwise. So you can either go this way, say this way, and this way, and this way. So if I go that direction, the first side, you can B here, you have a B, which is 62 degree. Then come across angle A, then come across side C, so side C now, this is actually C, we want to find out this one, and then angle B, then side A, we know it's 23 degree, and then there's a comma here. Okay, we're trying to find C now. which is opposite the two sides here. So Napier's rule say that, okay, then write down sine of middle with the sine of middle. So I just insert no sine of middle is the product of opposite of cosine. Okay, cosine product of opposite of cosine. Okay, product of cosine opposite. Okay, product of the cosine of opposite. In the note say this one, so I can use this one. Product of cosine of opposite. This is for product of cosine opposite. Now, if you happen to be use adjacent, there's a sine of middle part again is the product of tangent of adjacent. These are two formula for Napier's rule. Okay. So we have, remember the C have complement here. So actually what you have actually is a sine of com C. Okay, sine of com C, sorry, sine of com C length here is equal to product of cosine of A, cosine of B now. So the cosine of A, cosine of B. Okay, so we are actually using the first formula here. Okay, but sine of com C is same as cosine of C. So this is the same. Sine of com C is same as cosine of C. So this cosine of A we have 73 degrees. Cosine of B has 62 degrees. So you multiply out and can find C, right? So cosine 73 degrees times cosine 62 degrees so by 1372. So your C is cosine inverse of 0.13726 and cosine inverse here. Okay, you can find that 82.11. So this is how you find the side C using Napier's rule. Good, Napier's rule. Of course, you have to know how do you draw the Napier's rule. Okay, in order to do the calculation. equation. So I think most people not have problem remember because it is so fundamental how to draw it. Okay. So this is question 5, right? So B5. So I change the question B5 so that you have an Napier's wheel because otherwise will repeat. So you'll find that this Napier wheel formula in chapter 2, page 4. Okay, finally I'm going to go to B6 for you now. So B6 is a big question. You can see from B6 here and look at the information. Okay, also spherical triangle. Okay, spherical triangle, but you use a lot of application now. We have a law of sine, law of cosine. Okay, V5 sometimes also have law of sine, law of cosine, depend on the triangle you have. If you have a triangle which has no 90 degree, usually you have to use the law of sine, law of cosine here. Okay, but if you definitely have one angle 90 degree, usually you just apply Napier's rule. Okay, now I want to show you how to do B6 now. So B6 is a big application question. Okay, so I'm going to share an alpha with you. So I'm going to share an alpha with you, right? B6 here. Let me open up B6 here. This one I will try not write out for you really because I have worked out very nicely the solution. Okay, this is the original B6. Okay, original B6 in the practice exam. Let's do a question first. It has 3 parts. The ship sails eastward along a great circle track from position A with the coordinate there, okay, 20 degree north, 70 degree west, to position B, 40 degree north and 50 degree west. So along westward. So how the ship actually move from A to B? Okay, so you can see the direction of movement there. From the diagram, I have shown you the direction of movement is going east and going north. Okay, so the direction is actually eastward and northwards. Okay, so this is how the ship move here. So this is actually eastward, northwards. So in order to get a triangle, you bring in the north pole. Let P be the north pole. So you bring the north pole so that A to P is going north. Okay, B to P is also going north. So you bring the north pole now. The ship actually going east and north. So this is the first page. We haven't solved the question yet, but how to set up, understand the question. So this is the first page here. I have WhatsApp this to you. So now I try to figure out information what I can get from this triangle. Okay, I want to find the distance between A and B. What is the distance now? So how to calculate? You need to know what is PA, you need to know what is PB, you need to know what is the angle P. Right? What is angle P here? So let's try to figure out angle P first. Okay. So I'm going to build this one, I think smaller. Okay, how to find angle P? You look at the from A to B, how much the longitude has changed. So 70 west to 50 west. So difference of P now is actually 20 degree. Okay, there's a difference in longitude. From 70 west to 50 west, difference is 20 degrees. So that's how you know the angle P is 20 degrees, right? So this is how you find out angle P first. So let me present this to you. Then, how do you find PA and PB? Okay, P and PB here. So remember P is a north pole now, 90 degree north. Okay, P is north pole now, 90 degree north. So the distance from PA, distance PA is different in the latitude now. So it's 90 minus 20 equals 70, right? Okay, so actually should be this one, the PA here. So look at the working here. 90 minus 20 from P to A, and this minus 70 is 70 degree, right? So 70 degree is the distance from North Pole to A. Same thing here, distance from the North Pole to B is 50 degree now because 90 minus 50, 90 minus 40 is 50. So this is how you find the PA and PB. Everything is measured in degree first. So I actually have all the part of the triangle figured out already, then I can do a calculation. How to do calculation for distance AB, right? How to do calculation for distance AB now? So you can use a law of cosine now. Law of cosine, okay. So I know that distance AB, let's call it P now, small p. The cosine P equal to cosine A, cosine B, sine A, sine B, then cosine angle P. So now use the law of cosine. So will okay, law of cosine, I think you can see on page 10 of spherical triangle and also in the formula card. Okay, for spherical triangle, law of cosine. Already law of cosine, see that it's on page 210. Okay. So I'm going to find for spherical triangle side P, right? side P is actually, where is this one, side P, right? So cosine P now equal to cosine A, cosine B, plus sine A, sine B, then cosine angle P. So put in the information, all the information there, I've set the side P here. You'll find that side P is 26 degree, 26.3 degree. So this is how the answer. Find the length. Basically, you finish the length only. Distance between A and B in degree. Okay, this will find you the distance between A and B in degree. But usually, when you talk about distance, we want to know actual distance, not in degree. Okay, what is the distance between A and B? Can we calculate them? You know it's 26.23 degree. And then you must memorize formula, how to convert them in nautical miles. We know 1 degree is 60 nautical miles. So memorize that. The distance between A and B in great circle is 26.23 degree. So multiply by 60. This will be 1579.6 nautical miles. So this is how you answer part A. Okay, 1 degree is 60 nautical miles. So use the angle P, use the length P, 26.33, then convert into nautical miles. This answer for part A. Then how to answer part B? Calculate the initial cost at A. Okay, calculate the initial cost at A. So what does it mean? Okay, so this is how you find initial cost of A. So you go from A to the North Pole. Okay, so this is actually A here. You go from A to the North Pole. We are actually looking for the bearing of A to B. Okay, where is the initial cost? Initial cost is going from North Pole. Measure the North Pole. What is the angle from A to B? And this is called initial cost. Okay, initial cost at the point A. So how do you measure the angle A now? I use a law of sine. Okay, I use a law of sine in the calculation. Makes sine A over angle A, sine A over sine of angle A equal to sine P over sine of sine P over sine of angle P. Okay, make sure that you use a correct sine law. Okay, this is spherical triangle for spherical triangle, right? For spherical triangle. Okay, for normal triangle there is no the side don't have sine. Okay, the side have no sine. So I can find out the angle A, which is 36 degrees. But I will prefer to use a law of cosine. Okay, I prefer to use a. Why is it so? Because you will use a law of sine. Sometimes you have to figure out which one is correct answer. Okay, there are two possible answers. Okay, there are two possible answers. You use the law of sine. So if you use the law of cosine, answer is always correct. So I find the angle A to be 36 degrees using law of sine. Of course, you can use the law of cosine, which is actually a more preferred solution. So this is part B. Part C, I'll show you how to use law of cosine. Law of sine is easier to use up, but then eventually you have to decide. Yeah, there could be two possible answers, so you have to decide which one is the correct answer. So this is the initial cost. The part C now. Find the final cost at B. Basically, the bearing, which direction it moves now. Okay, B. So let me illustrate to you again before I move on. Okay, the ship go from A to B. So the ship actually move from this point to this point, B, right? And continue. What is the final cost of B? So you know the go B to the North Pole, and you measure the angle, and this is the final cost, direction it move. Okay, the final cost. This is the direction it move now. The ship actually move along this direction. Now, in order to find this direction, you need to find out angle B. And this is law of cosine come in now. Okay, and to find angle B, right? So how to find? You know the side B is 70, and then side A is 50, side P 26. So use the law of cosine to find out angle B. Okay, make angle B the subject here. Okay, then you can find out this angle B, cosine B is minus 0.6898. So from here, you find the B now, which is actually more than 90 degrees now, 133.55. Okay. So as I say, inside the solution, if possible, you try to avoid sine law. Because sine law will give you two possible answers, and you have to decide which one correct. But if you cosine law, you always get only one answer. So once the answer B already, then what is the bearing of the ship in the green color one? Is actually 46 degrees. Okay. And angle B is, this one is not the really one, B actually is 133.55. Okay, so 134 degrees now. So the correct answer is angle B, true bearing, this one. Okay, north 46 degrees east, true bearing. So this is the last part of B6 there. Let me WhatsApp this to you. So I have finished all the 6 solutions already. In the middle, I changed the question of B3, C, and B4. I also changed the question. B5, I also changed the question. B6, I keep the same question. So Maybe I stop recording already. Enough already. Mama Hasim is not here. Okay, just check again. Mama Hasim is not here. Okay, so I stop recording now. Enough already. Afterward, I send a video to you.